All right, here's a good question. It's a little bit tougher though because I've got two exponents that have x's in them. So it's a little awkward. So if 27 to the x is equal to 10 to the minus 3x. One problem also, like I've got to get those x's out of the exponent. But to do that, often I like to make these bases so they're the same. But there's no way I can. 27 and 10 won't share a common base. So what I have to do is do the property of logarithmic equality, PLE. So what you do is you log both sides. So if I log one side, I can log the other side. So log, and I'm going to use base 10. Base 10 of 27 to the x is equal to log base 10 of 10 to the minus 3x. Now I can use the power rule, which says I can take that exponent and pop it up front. So it'd be x times the log base 10 of 27 is equal to negative 3x times the log base 10 of 10. Now the answer to this part here, log base 10 of 10, if these are the same, then the answer to that is just 1. So really, I've got x times the log base 10 of 27 is equal to negative 3x. Now let's figure out on our calculator what log base 10 of 27 is. Let me just do that on my calculator. Okay, functions log of 27. 1.43. So on the left here, this will be 1.43x. I just put this first, is equal to negative 3x. Let's get the x's together. So 1.43x plus 3x is equal to, that would be 0. Add these would be 4.43x is equal to 0. Divide both sides by 4.43. Oh, and 0 anything divided by anything is just going to be equal to 0. So my answer to that question would be 0.